Questions on the homework? Question over any of the homework assignments? Questions over any of the homework assignments? Okay.
On number 17,
Let's look at 17. So at number 17, the first thing we need to do is factor. Now out of all these here, I would factor 2x squared plus 4x first. We can factor the 2x out. And when we factor 2x out of 2x squared plus 4x, we get 2x times x plus 2. Now it doesn't matter which one we factor next. So I'm going to go on and factor x squared plus 4x, or x squared minus 4x plus 3. Since the third term is positive, the signs are the same and match the sign of the middle term. Our factors of x squared are x and x, and our factors of 3 are 1 and 3. So we get this here. I mean, we can, but then we would have to factor from there, and it's going to be a little bit harder after we multiply. Now, we can do the denominator first, x squared plus 4x plus 4. Since the third term is positive, our signs are the same and match the sign of the middle term. Factors of x squared are x and x. 4 is 2 and 2. The numerator, third term is negative, so our signs are opposite. Factors of x squared are x and x. Factors of 4 end up being 4 and 1. And these here are all of our factors. Now we can put them together. We multiply them together. We'd have 2x times x plus 4 times x minus 1 times x plus 2. The denominator is x plus 2 times x plus 2 times x plus 1 times x minus 3. And at this point here, we can simplify out our like terms. So x plus 2 and x plus 2, x minus 1 and x minus 1, which leaves us with 2x times x plus 4 over x plus 2 times x minus 3. And that's our final answer. Questions on any of this here? Question on anything we've done so far? We good with questions on the homework? We ready for our notes? Need a second to write this down? Okay. We good? What we're doing today is dividing rational expressions. Now, dividing rational expressions, we have it written out here. But dividing rational expressions is, for all case and purposes, the exact same thing as multiplying, except for one main step. Because when we divide two rational expressions, first thing we do is we keep the first expression the same. We change it from division to multiplication and flip the second term. We keep, we change it, we flip. We keep it the same. The first rational expression stays the same. We change it from division to multiplication and then flip the second. And now our steps are the exact same as multiplication. Keep, change, flip, and then keep it the same. Let's put those away for now so we focus in here. Keep, change, flip. Now at this point here we need to factor. Well, since 7x is a single term, it's as simplified as it gets. The next thing I would look for is factoring any of these that have a greatest common factor. Well, one of our denominators is 2x minus 10. Well, the 2x and 10 have a greatest common factor of 2. So if we factor 2 out of 2x, we have x. Minus, if we factor the 2 out of 10, we have 5. So once we factor the 2 out of 2x minus 10, we have x minus 5, which is in simplest form. Is there any others that have a greatest common factor? Here's one. X squared minus 6x. We have two terms. They both have an x in common, so we can factor that x out, leaving us with x minus 6. X times x minus 6. And it leaves us with factoring x squared minus 11x plus 30. Now when we look at this here, we're looking at the third term. If the third term's positive, the signs are the same and match the sign of the middle term, which is negative and negative. Our factors of x squared are x and x. Now our factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. Which set of factors do we want? 5 and 6, because if it works out to be 5 and 6, we do have an x minus 6 in common on top and bottom. We have an x minus 5 in common on top and bottom. So that'd work out. Now if we check this, x times negative 6 would be negative 6x. Negative 5 times x, negative 5x, which does indeed give us negative 11x. Now we can multiply these together. So the numerator would be 7x times x minus 5 times x minus 6. The denominator, we can multiply the 2 and x, giving us 2x times x minus 5 times x minus 6. Well, throw that on the floor. What's in common on top and bottom? X minus 5, x minus 5, x minus 6, x minus 6. Because x over x is also 1. So that leaves us with what? Because we have x to the first over x to the first. 1 minus 1 is 0. Anything to the 0 power is 1. So it simplifies out, leaving us with 7/2. Questions on this here? We ready for the next part? Find the quotient 11x over 3x minus 9 divided by x squared minus 5x over x squared minus 8x plus 15. Again, first thing we should do is keep the first expression the same, change it from division to multiplication, and flip our second expression. it is part of the process when we divide fractions. So we're saying 1/4 divided by a half. We're breaking up a fourth into halves, which is actually doubling the amount. Because if we think of a fourth of it and we want to make half of this fourth, well, we've cut it in half and now we have two of them. So we have half of that fourth. Does that kind of make sense? It's a little weird how it works in the process that it works for that there. But we're able to actually do it by flipping it the other one. Does that make kind of sense? Now, at this point here, we need to factor. Well, the nice part is 11x stays 11x. Which one do we want to factor next? 3x minus 9, because it has the greatest common factor of 3. And we can factor the 3 out of 3x, which gives us x. And if we factor the 3 out of 9, we get 3. So we get 3 times x minus 3. Which one do we want to factor next? X squared minus 5x. And how can we factor it? Greatest common factor of x. And I always go with those. I go with the greatest common factor ones first because it does give us a roadmap. Because if it gives us factors, it can help us with the others. Because now figuring out the factors of x squared minus 8x plus 15, I'm hoping it either has an x minus 3 or an x minus 5. Because if it has one or both, it's going to simplify out. Third term, our 15 is positive, so signs are the same and match the sign of the middle term. That's helpful. Factors of x squared are x and x. Factors of 15, 3 and 5. And we can pick 3 and 5. Now we can check it just to make sure we do get negative 8x. X times negative 5 is negative 5x. Negative 3 times x is negative 3x, giving us, lo and behold, negative 8x. Questions on this here? Well, in our second set of parentheses, we already have an x minus 5 over x minus 5, yes? There's nothing that says that we can't simplify at this point. We can simplify it now, or we can multiply it together and simplify it then. Either way. Because when we multiply these together, we're really saying that we just have 11x times x minus 3 over our 3 times x is 3x times x minus 3. So indeed, the x minus 3 and x minus 3 will cancel out. Anything else? The x's, leaving us with 11 over 3. Questions on this here? We ready for the next one? Keep, change, flip. So our first one stays 4x over 5x minus 20. We change it from division to multiplication and flip the second one. So the second one is now x squared minus 6x plus 8 over x squared minus 2x. Which one of these do we want to factor first? 5x minus 20, because it has the greatest common factor of 5. And if we factor it out, we get 5 times x minus 4. What about the next one? X squared minus 2x. And we can factor it by taking out the greatest common factor of x, leaving us with x minus 2. X times x minus 2. X squared minus 6x plus 8 does not have a greatest common factor. Third term's positive, so signs are the same. Match sign of the middle term. Negative, negative. Factors of x squared are x and x. Factors of 8 are 1 and 8, 2 and 4. Which one do we want to try first? 2, 4. And if we do check this, x times negative 4, negative 4x. Negative 2 times x is negative 2x, giving us the negative 6x that we wanted. Well, really when we multiply, we're just putting everything together, yes? So, I mean, one of our shortcuts is that we can just connect them together. And we can see for certain that x minus 2 and x minus 2 will cancel, yes? And x minus 4. X and x leaving us with 4 over 5. This works, but we do need to make sure that we keep track of all of our terms, especially if they don't all cancel out. Questions on this here? Questions on any of this so far? (45). We have 4a squared minus 1 over a squared minus 4. But we're needing to change it from division 2 and flip the second over 2a minus 1. Luckily for us, a minus 2 and 2a minus 1 are already simplified. We don't have to do anything to those. But we will need to factor our 4a squared minus 1 and a squared minus 4. Which one of those do we want to factor first? A squared minus 4. Because it is a difference of perfect squares. Yes? So what would it factor to? A plus 2 and a minus 2. Because that's just our formula for difference of perfect squares. Yes? How about our 4a squared minus 1? So 2a minus 1 and 2a plus 1. So this looks very much like the difference of perfect squares, yes? Signs are opposite. First terms are the same. Second terms are the same. Well, 4a squared is a perfect square, 2a and 2a, yes? 1's a perfect square, 1 and 1. So our 4a squared is a difference of perfect squares. Exactly. Because 2a minus 1 and a minus 2 do have parentheses around them. We just don't write it because there's nothing else being multiplied by it, but we can put those in. And what else is in common? So a minus 2 on top and bottom, and yes, 2a minus 1. 2a minus 1. Which leaves us with what? Because they're stuck together. The a plus 2 is one whole term. The 2a plus 1 is one whole term. Because if we wanted to try to split this apart, it is possible. But when we add two fractions, the denominators have to be the same. So they would both be a plus 2. Our numerators we can split apart. It would be 2a and 1. But we don't have a over a. We have a over a plus 2. It's not the same as with multiplication. We can't just simplify that. Does that make sense? What do we think with these here? Not too bad. Why not? Let's do this one here. I skipped over this one in the last few hours, but it's not too bad. Our first one, y squared minus 9 over y squared, stays the same. Our other one, we flip and we do change it from division to multiplication. Our y squared, simple as it gets, is only one term. Y plus 2 does not have a greatest common factor, and the degree is 1. Because again, we get our degree by the variable with the biggest exponent in that expression. So on top, y plus 2. Biggest exponent attached to a variable is 1, so that degree is 1. Which one do we want to factor first? Y squared minus 9 or y to the 5th plus 3y to the 4th? Y squared minus 9, how would that factor? Y minus 3, y plus 3, because that is a difference of perfect squares. Y to the 5th plus 3y to the 4th. How can we factor that? Greatest common factor of y to the 4th, which would leave us with y plus 3. Is there something in common on top and bottom? Y plus 3. And they would cancel. The denominator would be what? Y to the 6. Because we have y squared times y to the 4th. 2 plus 4 is 6. I have 2 of them. I put another 4 with it. We have a total of 6. The numerator, we had y minus 3 times y plus 2. Leave it as this here. Do not multiply it back out. All right. I mean, there's not a whole lot of reason to multiply it back out because that is the final answer. There is not a simpler form. You're not going to have to give me y squared minus y minus 6 over y to the 6. There's no reason for this. Does that make sense? And I mean, at this here where you're asking if we could cancel it out, we technically could, but it doesn't make it simpler. Because we could break it up like I did with the previous one and have y squared over y to the 6 minus y over y to the 6 minus 6 over y to the 6. That's 1 over y to the 4th minus 1 over y to the 5th minus 6 over y to the 6th. Is this here any simpler than that? No. So there's not a whole lot of reason to break it down further than that, unless it is asking you to do a decomposition. But there is the final answer. Questions on this here? We're going to do 52 and then we'll move on to the last type, do 2 more after that, and then we are done for today. Yes. Keep, change, flip. Keep, change, flip. Out of these 4 here, which one do we want to factor first? A squared minus 16 is a difference of perfect squares and would factor to what? 4. A plus 4 times A minus 4. Which one do we want to do next? A cubed is a perfect cube. Now the question is 4A. It is not. But there is something in common with both of them. They have a greatest common factor of A, which gives us A squared plus 4, yes? Now looking at that, is A squared a perfect square? Yeah, A times A is 4 a perfect square. 2 and 2. So is A squared plus 4 a difference of perfect squares? So But what's the key term in that? It's a difference of perfect squares, yes? Is a squared plus 4 a difference? Because what is a difference? We're talking about subtracting 2, yes? 2 perfect squares being subtracted. A squared plus 4 is not being subtracted, it's being added. So is it a difference of perfect squares? No, we don't have a formula for it. A squared plus 4 does not factor. What's the difference? Because the difference between a squared minus 16 and a squared plus 4 is the two terms are not being subtracted. Because if we said it was a minus 2 times a plus 2, a times a is, a times positive 2 is plus 2a. Negative 2 times a is negative 2a. Negative 2 times, and these will cancel. What's negative 2 times 2? Now the middle terms do cancel, giving us a squared minus 4. What do we have over there? We have a squared plus 4. It's right. The only way that this would work is if we had negative 2i and positive 2i. This is partially because I know how it actually, what the answer is to this. Because if we did the same thing here, the middle terms would be 2ai and negative 2ai. But again, those still cancel. Our 2i, negative 2i times positive 2i would be negative 4i squared. But I squared is negative 1, giving us a squared plus 4. So the only way to have the sum of two squares is if one of our terms is I, imaginary. So there is no sum of two cubes, or sum of two squares. No sum of two squares. We can have sum of two cubes, but not sum of two squares. Does that make sense between the two? Because again, difference of two squares, we have a formula. We do not have a sum of two squares. We can't add two squares together and factor it. So a squared plus 4 is not factorable. Now we have the other two. Now we need to pick which one of these you want to factor first. A squared plus a minus 20, or a squared plus 8a minus, or plus 15. A squared plus a minus 20. Since the third term is negative, our signs are opposite. Factors of a squared are a and a. Factors of 20, 1 and 20, 4 and 4 and 5. Which one's positive, which one's negative? Well, we can just pick 4 negative, 5 positive. And if we check this here, a times negative 4 is negative 4a. 5 times a is plus 5a, giving us a positive a that we wanted. So those are our two factors. Last thing we need to factor is a squared plus 8a plus 15. Third term's positive, so the signs are the same and match the sign of the middle term, plus and plus. Factors of a squared are a and a. Factors of 15. 1, 15, 3 and 5. 3 and 5. Well, they're both plus. It really doesn't matter where we put them. A times 5 is positive 5a. 3 times a is positive 3a, giving us positive 8a. Multiply them together, well, that's really just smashing them onto one fraction bar, yes? So we can rewrite it, or we can combine them. What's in common on top and bottom? A plus 5 and a plus 5, yes? What else? A minus 4 and a minus 4. Anything else? No. It looks like it might be tempting to want to cancel out the a plus 4 and the a squared plus 4, but since the a is not the same, it's a squared and a, we can't cancel that out. So that leaves us with a times a squared plus 4 on top, and the denominator would be a plus 4 times plus 3. Questions on this here? Would we say this is overly or completely different from multiplication? Well, not too much, no. It's one or two steps. Keep, change, flip. Then everything else is the exact same. And that's the nice thing with dividing two rational expressions. Just like these here. The first main step that we do is we keep the first one the same. We change it from division to multiplication. We flip the second one, but wait, the second one doesn't have a denominator written, but it does have one. What is the denominator? 1. So when we flip it, the new numerator is 1, and the denominator now is 3x squared plus 5x. Questions on this here? Out of the last two that we need to factor, which one do we want to factor first? 6x squared plus x minus 15? Okay. Two sets of parentheses with 3 spaces. Since our third term is negative, our signs are opposite, plus and minus. Factors of 6x squared, well, we will have x and x. Now our factors of 6 are 1 and 6, or 2 and 3. Which one do we want to try first? 2 and 3. Where do we want to put the 2? Where do we want to put the 3? 2 or 3 first? We can just pick one. 2, 3. Factors of 15 are 1 and 15, 3 and 5. Now we can't put the 3 and 3x together because that would give us a greatest common factor. And even though I didn't state it, 6x squared plus x minus 15 does not have a greatest common factor at all. So we have to put the 3 with the 2x, 5 with our 3x. Now when we check this here, 2x times negative 5 is negative 10x. 3 times 3x is plus x, giving us negative x. Is that the middle term we wanted? We need to flip the signs. All right. I thought I was going to go an entire class period without dropping something, but it is not the case. Now, if we check this again, 2x times 5 is 10x. Negative 3 times 3x is negative 9x, giving us the positive x term we wanted. Now, the only other place we have to factor is our 3x squared plus 5x. These two terms have a greatest common factor of x, which leaves us with 3x plus 5. Do you have anything in common on top and bottom with our 3x plus 5, leaving us with 2x minus 3 as well. 2x minus 3 times 1 is just 2x minus 3. The denominator is 4x. Our x squared times x is x to the third. So all we have left is 2x minus 3 over 4x cubed. Questions on this here? We're ready to look at the last one. So we have this one and one more. I'll let y'all pick. Do we want to do this one here or the last one? This one or the next one? This one here. All right. Keep, change, flip. So our first one's going to be 2x squared plus 3x minus 5 over 6x. Flip, the new numerator is 1. And our denominator is 2x squared plus 5x. Keep change flip. Now, at this point here, I would factor the 2x squared plus 5x. Since it is two terms, we're most likely looking for a greatest common factor. And the greatest common factor is x. So when we factor it out, we have 2x plus 5. Now, that is helpful because it means one of our factors of the other numerator is hopefully 2x plus 5. Because if it is, those two will cancel out and simplify down. If not, it won't. The third term is negative, so our signs are opposite. Factors of 2x squared, well, we'll have x and x. And the factors of 2 are 2 and 1. So where do we want to put the 2? In the first set of parentheses or second? We'll put it with the first one because we wanted to match up with that 2x plus 5. Factors of 5 are 5 and 1. So we'll put the 5 with the 2x to give us that 2x plus 5. And put the 1 in the other spot. Now if we check this here, 2x times negative 1 would be negative 2x. 5 times x is plus 5x, giving us the positive 3x we wanted. Multiply and simplify. What's in common on top and bottom? 2x plus 5, so those will cancel. The only thing left on top is our x minus 1 being multiplied with 1, which is x minus 1. The denominator, 6x and x, gives us 6x squared. And that's it. Questions on this here? And that's it.